So I'm here with a collection of three-dimensional tactile models of different aspects of the planetary terrain that we're encountering on the Moon and on Mars and a little bit of Earth as well. And what we've done is we've used these tactile models to develop a program to help teach astronomy, planetary science, to students who are blind or visually impaired. So it allows them to explore by touch what you and I might explore by sight, right? Planetary science and astronomy, they're very visual fields, intensely visual fields, and are oftentimes closed off to people who have visual impairments. And so this is a way for us to open up for more exploration of using a tactile nature of that. So let me explain a little bit about how it works. We take data from orbiting spacecraft that are returning information about the topography of a planet, so the elevation profile of features on the surface of the planet. And using that data and 3D printing technology, we produce prototype models of various places. So, for example, we have this model. This is the far side of the Moon, all right? So an entire hemisphere of the Moon, and it's rendered tactilely. So a student can explore the heavily cratered highlands on the far side of the Moon, and explore these kind of complex craters that we're finding on the far side of the Moon, and learn a little bit more about the Moon from that process. And then we can explore more closely details of that. So here is a model of the crater Tycho on the Moon. It has that large central peak, central mountain in there, and you and I can see that with our eye with the right kind of illumination from even telescopic views, and this allows a student to explore that crater and the details of that crater by touch instead. So using this process, we can actually go to any planet that we have elevation profile data from, even if it's not the whole planet, just pieces of it, and we can reproduce tactilely that data. And so here's a hemisphere of Mars where you see Mariner Valley and the giant volcanoes, and allowing students to explore that. The other thing that we can do with this technology is produce models of spacecraft. So here we have four models, the Curiosity rover and Spirit, the solar-powered rover, both on Mars. And these are fully assembled, and the students in our program get the components of the spacecraft, and by touch they assemble the spacecraft, the different parts of it. So solar panels for power, the radio antenna. Here's one of my more favorite ones. This is the HiRISE telescope on the Mars Reconnaissance Orbiter. So they have to put that together, and then they have to put it onto the spacecraft, and then explore a little bit more about it. So by using this combination of modern spacecraft data with modern 3D printing technology, we can really open up the field to a diverse collection of students that maybe would not have that opportunity otherwise. At least it's something for you to think about and start looking into for your plans. All right, so I'm Dr. K at UA, and I hope to see you sometime in the future. Bye-bye.